Okay, so the setup is we've got a charged particle moving through a magnetic field. We know the velocity of the charged particle, we know the charge, and we know the magnetic field itself. And then the cross product, or this equation, gives us the magnetic force on that charged particle as it moves through. Basically, we just need to take a cross product and then scale it. So the question is, how do we take this cross product? And we can rewrite these in their sort of angle bracket form to see how to do that pretty quickly. So V, how do I represent V in its angle bracket form?
0, 0, 20.
Okay, thank you, 0, 0, 20. And then V.
1, 1, 0.
Good, good. When I take their cross product, remember I'm thinking of the ijk up here and do the matrix multiplication. So I've got 0 minus 20. And then negative. Cover up the second column. I get 0 minus 20 again. Third column, we get 0 minus 0. So this is what V cross V looks like. And then the charge is 1, so I don't have to change this any. And this is the magnetic force. Now we're supposed to sketch this thing. And the idea is that the sketch could help to sort of illuminate or point out some properties that make sense to us. So what exactly does it ask us to sketch?
The magnetic field, the velocity, and the force of the motion.
Okay. So we're supposed to sketch all of these on the same XYZ coordinate system. I will try to do this nicely. All right, let's do B first. First of all, I know that I'm going to need some fairly long lengths here, length of 20 in a couple of different directions. So since B is just 1, 1, 0, it's going to be pretty small in my picture. But I do want to be able to see it and see which direction it's pointing. It goes 1 unit in the X, 1 unit in the Y. So let's color code this blue. I'll do this one red, and then this blue, and this other one green. Help us visualize it a little bit. All right, so the red vector looks something like this. It doesn't point up or down at all. It's just it sits in the XY plane. And then the blue vector, 20K, what does that look like on this picture?
Straight up.
Yeah, straight up. Has a length of 20, so let's just say that this is 20. Looks like that. So the magnetic field, this is a velocity vector, so the particle is moving orthogonal to the magnetic field. The magnetic field, I just drew one arrow, but really what I should be drawing is this same arrow all over the place, because the magnetic field is all through space here. This velocity is just, I'm thinking of it just starting at the origin and only having one vector, because it's the velocity of a particular particle. So really what I'm thinking of is this thing is getting pushed this way as it moves up. So in time, as it goes up, it's starting to curve this way, and then the magnetic field is going to do something to it. Oh, no, that's not true. The magnetic field goes this way. This is part of the point of the problem. Even though the magnetic field is pointing this way, that doesn't mean the particle is going to get pushed this way. The direction that the particle is going to get pushed is determined by this force. So let's draw that. Negative 20 in the x direction, positive 20 in the y direction. So negative 20 in the x direction takes us out to something like this. And positive 20 in the y direction, somewhere around here. So the direction that this particle is getting pushed is back into the wall. I think the main thing for us to notice is that if you take the plane containing this, this velocity vector and the magnetic field, so that looks like a plane coming through this z-axis and coming out at a 45-degree angle. The direction that the magnetic force is pushing is orthogonal to that. So we've got our plane coming out, and then the force is orthogonal to that plane. Have any of you guys taken Physics 2 yet? Okay. Did you do an experiment where you ran, it's like an electric current through a contraption, and there was a magnetic force in it, and you could see it glow and make a pattern of the direction that the electrons were flowing?
I don't know if it was glowing, but I know we did something pretty similar.
Okay. Well, this can help explain what's going on when, if you tilt the magnetic force a certain way, then you can make the electrons move in a spiral. And as you tilt the magnetic field, you can make the electrons move in different ways.